Okay, so for example 2, it's another limit problem. We've got another graph and we're trying to figure out these one-sided and infinite type limit things. So let's look at part A. Um, x goes to 2 from the negative side of 2, so from the left side of 2. So here's 2, right along here, and we want to approach it from the left side, so this side. And as we get close to 2 from the left side, the y value is close to 1 right there. So this is going to equal a 1. And as we get close to 2 from the right side, which is what B's asking, so as we get close to x equals 2 on the right side, the y value is also close to 1. Let's see, and as we get close to 2 in general, so this thing means limit as x goes to 2 from the right side. If the limit on the right side is the same as the limit on the left side, so if this is the case, then we can just say that the general limit is the same, equals whatever value this is. So since it's 1 on the left and 1 on the right, we can just say that the whole limit's 1. The value of g, though, is up here, so that's 2, 3. If we look at what happens at the limit as x goes to 0, well, as x gets close to 0, so that's coming in from both sides. In both cases, we go up to infinity here, so we can either say infinity or does not exist. And as x goes to infinity, the function looks like it goes close to 0 here, way out at the end. So let's talk about what these different things mean when you put them together. These two together, since they both equal 1, they mean this. So these are interchangeable. This part C is interchangeable with A and B. If you put together, let's say, D and either one of these two things that we just talked about, so like D and C put together, notice that the limit as x goes to some number of that function equals some other number. So I'll just do it this way, 2 and 1. But the function itself equals something else at that point. So this thing right here, let's say you didn't know what the picture looked like, so just ignore this. As I get close to x equals 2, so let's say this is x equals 2 along this line right here. So I'll just put it on the axis. So there's x equals 2, right? Anything along this vertical bar that goes through 2. So the value of g is close to 1. It equals 1. So the closer I get to 2, from either side, the closer this function's value gets to 1. But notice at 2, it doesn't actually equal 1. It equals 3. 2, 3. Just like that. So what you can determine from these two pieces of information put together is that there is a discontinuity at x equals 2, and it's a removable one because it's just a hole right there. So removable discontinuity at x equals 2. That's something that we can get from this info. This info right here, just any limit that involves an infinity, tells us we've got an infinite discontinuity at x equals 0. And in this case, you can even tell that both sides have to go up to infinity at x equals 0. And this right here tells us that way out at the end of the graph, the value of the function gets closer and closer to 0. And if you go back and look at our picture, well, that's what we have. We have a hole at 2, a removable discontinuity with a dot filled up above it. We have the limit way out here is 0. So horizontal asymptote at x equals 0. Or at, y equals 0. That's the value that it approaches. And when we're close to 0 on both the left and the right sides, the function shoots off to infinity, which is what we get here and here. Okay, hope that helps.